Hello students, next we are going to look at what is called as Supermesh analysis. It is same as mesh analysis, but instead of having a mesh, we sometimes have a supermesh. Where does the supermesh come from? For understanding that, look at this particular problem. Here we are having a three mesh network, and the network has two sources, two independent sources. One is a 2 volt power source, voltage source, and another one is this 4 amperes current source. Now we already know that when we are doing mesh analysis, it should always be a voltage source. And if at all there is a current source, that current source should be present only in one of the mesh. Here we are having the situation where this current source is being shared between mesh 2 and mesh 3. So what is the trouble with this? The trouble with this is that, see, if I am going to write the mesh equation for this particular scenario where I am having I2 current flowing in this mesh 2, then I will write basically, since this resistance is 5 ohms and the current is flowing in this direction, so plus minus. Here for this resistance, I2 current is basically flowing in this direction, so I will write plus minus. So there all I can write. But what about this one? This one I cannot write anything because a current source does not have a voltage across it. It does not have a voltage source across it because the 4 ohm resistance, the not 4 ohm resistance, the 4 ohm 4 ampere current source is actually a current source. So what we are having basically is only a current source and not a voltage across it. So we will not be able to write any polarity, or we will not be able to write any KVL equation for this second loop. Same is the case with the third loop, the third mesh. Because of I3 I can write plus here, I can write minus here, but what about the polarity or the voltage across 4 ampere current source? So it's not possible. So what we do instead is we imagine that we are going to have something that is called as a super mesh, where we combined both the mesh together and we draw something that is called as a super mesh. So we have combined the two mesh together and we have got a super mesh. So that is basically a super mesh. So let me write that. So this here is basically a super mesh. What I will try to do is, because it's a question, so I will not change the things in the question. What I will do is I will redraw this and we will have the super mesh drawn straight away here. So this is going to be the super mesh. So when I am having the super mesh, see, I am considering the circuitous path that is drawn by this red color, and when I say that it's a super mesh, it means that it is combining two meshes together. So this is a super mesh. So now I'm going to write only the equation for two meshes, the first mesh and the super mesh. So let me write KVL at mesh 1. So if I'm going to directly write, the current is going to flow from here. So this is plus, this is minus, this is plus, this is minus. Based on polarity, this is plus, this is minus. I will take the back of the bogie, so I will be writing minus 2 plus 1I1 plus 10 times I1 minus I2, and that's going to be equal to 0. So that one is done. Therefore I will take minus 2 the other side, and I will combine 1 plus 10 together for I1, and for I2 I will write minus 10 I2, 2 I have got the other side. So this is basically what this is: 11 I1 minus 10 I2 is equal to 2. So this is my first equation for the first mesh. Okay, now for the second one I will write the KVL at Supermesh. So basically I will write the polarity. Since the current I2 is like this, it's plus minus here. The polarity here, it will be plus minus here. Here the current I3 is flowing from top to bottom, so plus minus here. Now I am not going to change the current. The current is going to be I2 and I3 itself. So for these two resistances, it's the current I2 that is flowing, and for this resistance it's the current I3 that is flowing. So I'm not going to change that. So even if I draw a super mesh, I'm not going to write a new current. So how does that work? So let us write the equation. So I'm going to take back of the bogie again. So 10 times I2 minus I1, then plus 5 times I2. It's not I1, it should be it's I1, yeah. So it is 5 I2. Then I am having I3, which is again back of the bogie. If I am going to take, then it's going to be plus 15 I3. 15 I3 is equal to 0, from which I can take the I2 values to be 15 I2, and before that there is I1. So let me first write in order. If I have to write, then I will first write for I1, because that is what is the correct way. So I am having for I1 minus 10 I1, I2 I am having plus 15 I2, and for I3 I am having 15 I3 is equal to 0. So how many unknowns are there? There are 3 unknowns: I1, I2, I3. 3 unknowns, isn't it? 3 unknowns for 3 current. One is for I1, one is for I2, one is for I3. But I have got only 2 equations. First equation is this one, the second equation is this one, and we all know that for finding 3 unknowns we require 3 equations. So where will I get the third equation? See, the third equation I will get from this branch itself, because this branch is having 4 amperes current. So whatever be I2 and I3, that should not go more than or less than 4 amperes, isn't it? So if I am having 4 amperes here, then I2 and I3 should combine to give me 4 amperes. Now what is the direction of 4 ampere current source? It is going from bottom to top. So I will say that this I3 minus this I2 should give me 4 amperes. Okay. Now how do we write it very very nicely? Or see, if we are going to consider this as a node, then here the current is I3 and here the current is I2. Okay, I3 and I2. So I can basically write this and get the KCL equation. So here I am having the node, here the current is I3 and here the current is I2. Okay, and what is the current here? Here the current is 4 amps. Therefore I will name this node first. I will first name this node. This node is going to be, let's say, A. So I will write at node A, KCL gives. So I am using the Kirchhoff's current law. What is the Kirchhoff's current law saying? At a junction, the sum of all current should be equal to 0. And what is the rule that we have for KCL? Incoming current is always positive. Incoming to the junction is always going to be positive. So that thing I have to take care of. So I3 is incoming. So I will get plus I3. I2 is outgoing from the junction. So minus I2, and 4 amperes is also outgoing. So minus 4 is equal to 0. So this was the second equation. Now I have got the third equation. The third equation is basically minus I2 plus I3 is equal to 4. So this is the third equation. So now I have got here I1, here I have got I1 having value of 11, I2 with 10, I3 with 0. Okay, you all know this because there are 3 equations. So in every equation there should be 3 components. Here even if we don't have, I can write it as I3, but obviously the coefficient of that will be 0. So plus 0 I3. Okay, here I am having all the 3 components. So no problem. Here I am not having I1. So I can actually write 0 I1 minus I2. But that is all well understood. And using the simultaneous equation, solving for simultaneous equation, sorry, I have to change the pen. Okay, solving the simultaneous equation 1, 2 and 3, I will get value of I1 as minus 2.35 and I2 as minus 2.78 and the value of I3 I will get it as 1.22 amperes. So that's how we get the 3 current. And now what is the question? The question is asked as what is current through the 10 ohm resistor, isn't it? So I will write therefore current through 10 ohm resistance is going to be I1 minus I2 if I want to write, or even if I2 minus I1, it does not matter. I will just write I1 minus I2. I1 is minus 2.35 minus of I2 current is 2.78, which gives me the answer to be 0.43 amperes. So even if this answer would have been minus 0.3 amperes, it only means that the direction of current is inverse. Direction of current is reverse. That's all. Here the answer is 0.43. Thank you.